Hi, my name is Adrian Rochek, and my computer technology project is on collision detection for the blind. Background and objective. The white cane is used by the blind and vision impaired as a mobility aid. It is by far the most economical and efficient method employed to aid users to move about independently. However, it has several drawbacks. For example, canes make no allowance for overhangs such as branches hanging over walkways, and is poor at detecting drop-offs like stairs leading down. It also doesn't warn the user of any upcoming obstacles. By implementing other technologies such as ultrasound, infrared, LiDAR, and audio feedback, the cane can be modified to warn the user of these obstacles. The device needs to be integral to the cane, compact, and unobtrusive. Methods of detection and range finding. Ultrasound. Ultrasonic sensors utilize the properties of sound. These sound waves are emitted with frequencies above the range of human hearing. It can be used to detect objects and measure distances by generating ultrasonic pulses in a particular direction. If there is an object in the path of this pulse, it will be reflected and read by the receiver. The time it takes for the reflected echo to reach the receiver is used to calculate the distance from the object. Infrared. Infrared radiation is a type of electromagnetic radiation. The light emitted is part of the electromagnetic spectrum, invisible to the human eye, but is felt as heat. The radiation is transmitted in waves at different wavelengths and frequencies. Infrared sensors work by detecting a select light wavelength in the IR spectrum. An LED light acting as a transmitter is used to produce light at the desired wavelength you are trying to detect, and the light bounced back from objects is read by the infrared sensor acting as a receiver. LiDAR. LiDAR stands for Light Detection and Ranging. This technology works on the principle of radar, but uses pulses of light from a laser to measure distances from a target. The pulsed laser beam is transmitted, then reflected from objects such as trees, vegetation, buildings, people, and cars. Once the pulses return, they are recorded and the distance between the sensor and the object is calculated using the time of flight principle. Advantages and disadvantages. Here I have outlined some of the advantages and disadvantages of each detection method. Ultrasound. Some of the advantages include being able to measure transparent objects like the surface of water. These sensors are also quite cheap and readily available and are easy to implement. Disadvantages. These sensors have a short measuring range, low accuracy, and are quite sensitive to weather conditions. They also have low efficiency, measuring objects reflecting echoes at a high angle. Infrared. Some of the advantages include being able to detect living and non-living objects. The sensor can also be applied to a large area and operate in real time. It can also detect leaks in underground pipes, and the sensors are quite cheap and readily available. Some of the disadvantages include the transmitter and receiver need to be in line of sight. The device it is attached to needs to be stationary while the transmission is in progress for best accuracy. The sensor is unable to detect objects with a similar temperature, making it hard to distinguish between objects. It also has quite a short measuring range. LiDAR. Some of the advantages include having long-range measuring and a large field of view. This helps detect curved obstacles and bounce-off angles. The sensor is also suitable for indoor and outdoor applications, therefore works very well outside in the sunlight and doesn't need recalibration due to filters and optics. This makes it more resistant to the sun. It can also take readings very quickly at a rate of up to 500 Hz. Some of the disadvantages include being rather expensive, and also having difficulty measuring transparent objects. Approach. I've decided to use LiDAR for obstacle and collision detection because it will give fast, accurate readings and work well in outdoor environments during different weather conditions. Mounting the sensor on a cane and utilizing its motion will also give a great field of view and desired range of up to 5 meters. The sensor will also allow me to take readings while moving. LiDAR produces data as a point cloud, which has thousands of three-dimensional arrays, each having X, Y, and Z positions. This mapping can be used to create a 3D image of the user's surroundings to help with collision detection. LiDAR is used in many modern-day applications, such as collision detection and obstacle avoidance for drones and autonomous cars. I will be utilizing a microcontroller to perform processing tasks for the project. A microcontroller is a small computer on a single integrated circuit. C programming will be used to give functionality to the LiDAR device by compiling and uploading code to the microcontroller using the Inertia or Arduino IDE. The LiDAR Lite version 3 sensor chosen for the project is manufactured by Garmin, and they provide an array of libraries with code. I have chosen to use these libraries and implement their code while building on them to achieve the best functionality. There are already existing projects utilizing this hardware for different applications like drone and autonomous cars. I will be researching their techniques and build off them to use in my final project. Hardware and resources. The basic components required to create the detection system are as follows and are subjected to change later down the track. Hardware required. The sensor I plan to use is the LiDAR Lite version 3 manufactured by Garmin. I'll be using this for range finding and obstacle detection. I will also be using a USB battery pack which is 5 volts to provide power to the microcontroller and any attached devices. The microcontroller I plan to use is going to be either the Texas Instrumental MSP430, which I also have readily available with me, or an Arduino board. To connect the power to the microcontroller, I'll be using a USB to micro USB connection, and to notify the user of any impeding collisions, I'll be using a LilyPad Vibe motor and a mini speaker. Software required. Depending on the microcontroller I use will dictate what kind of IDE I use. If I use the MSP430, I can use the Inertia IDE, and if I use the Arduino, I can use the Arduino IDE to compile my code. I also plan to utilize the Inertia or Arduino libraries to help program functionality for the hardware. Because Garmin now owns the LiDAR Lite hardware that I'll be using for my project, they have also released a bunch of libraries to access basic functions for the LiDAR Lite device. These libraries can be used to read distances using PWM or I2C interface. Garmin has also provided specifications, pinouts, and connection diagrams in their manual which I'll utilize for my project. Initial design. This initial design was created using a software called Fritzing for testing purposes. It uses the minimal components to provide basic functionality of obstacle detection and range measurements using the I2C interface. The schematic is subject to change later down the track when I decide to use a smaller microcontroller for better form factor. The LiDAR sensor will be connected to MSP430 microcontroller using the I2C interface. This is achieved by connecting the SDA and SCL lines to the board. The VCC and ground lines from the sensor will be connected to the board by passing through a capacitor. The microcontroller will also be powered using a 5-volt power source, and it will be connected to the board using a USB to micro USB connection. Design considerations and issues. The following needs to be considered for the final design. I'll have to make sure that the whole entire unit has really good form factor, be safe and secure, be reliable, have low cost, be easy to use, and have low power consumption. I will also need to consider the type of interface to use. I can either use I2C or PWM. The decision will be dependent on whether or not I will want to implement a second microcontroller to the unit down the track. If I choose to do this, I will have to go with I2C. Some other issues I need to overcome going forward will be sourcing components at a reasonable cost, refamiliarizing myself with C++ and wiring language because it's been a while since I've done them, and also refamiliarizing myself with soldering. This concludes my presentation. Thank you very much for listening, and here are the resources I have used to help research techniques to approach my project.